Hello everyone, my name is Hussein and I will be talking about the Xbee. Here's an overview. I will be talking about how the two XPs communicate with each other, the problem we're trying to solve, potential solutions to overcome that problem, and then the company response. Alright, so we're currently trying to send 2048 bytes with 9600 baud rate. When Linnea did the testing, we had the baud rate set to 19,200 bytes per second. As a general rule, lower data rates allow the radio module to have better receive sensitivity and thus more range. What is receive sensitivity, you might ask? Well, it means the minimum magnitude of input signal required to produce a specified output. In other words, transmit power is how loud someone is yelling, and receive sensitivity would be how soft a voice someone can be. This is the sound analogy by the DJ International. The XP receives 2048 from the Raspberry Pi and packets it in 255 byte buffer. This 255 is the maximum packets the XP can send in a buffer. An alternative option is send the bytes as they arrive from the Raspberry Pi. I have not found any good articles that say which is better, but this is something definitely we should find out on our own. The problem we're trying to solve is that we're not getting the expected distance. The company claims with a high gain antenna, we should have a range of distance 9 miles of distance. So, although we're not using a high gain antenna, ideally we should be getting a maximum distance of 1.9 miles. And this is assuming the Fresnel zone is not interfering with the ground. We need to first understand the Fresnel zone. Here's the Fresnel zone 1, and here's Fresnel zone 2, and then here's Fresnel zone 3. And this is ground, this is the line of sight. Suppose you're trying to send signal from antenna A to antenna B. Some of these signals will hit the ground, some of it will be absorbed by the ground, some of it will bounce off the ground, and this action will result in 1/2 length shifts in the time. The best way to illustrate this is through a graph. Let's graph this. This is an original frequency wavelength, and we're after doing this in the Fresnel zone 1, and it's after it's been shifted with 1/2 length. This is the resulted signal. So what happens is these two signals interfere with each other, since this hit the ground and then this is the original one. We're getting two signals that are interfering with each other and canceling out, which results in nothing. Let's elevate these two antennas and have the Fresnel zone 2 to be touching the ground. Same setup, the signal is absorbed by the ground and some of it is bounced off. Now, after, since this is going to shift if it's touching the Fresnel zone, suppose this is shifted 1/2 of its length. This means it's shifting to the other direction. This means both signal will be in the same period, which means if we add them up, it will double the size of the amplitude of the signal. So, one solution to this problem is to place the antenna high above the ground and any obstacle that might interfere with the signal, such as buildings, trees. To calculate the Fresnel zone, we need to know the distance between the two antennas. So here is the formula to calculate it. R is the radius of the Fresnel zone, 8.657 is a constant, and then we take the square root of the distance in kilometers over the frequency in gigahertz. And I did this assuming that I'm doing it with 1.2 miles away from each other with 900 megahertz frequency. And then we will be having 12.5 meters. Suppose you want to extend the distance between these two antennas. If you extend these two distances, if you extend these two antennas, you will increase the Fresnel zone, right? And so the way to do it is if you can elevate one antenna above the other one. So when I asked the company about how their setup of the Xbee when they got the 9 miles, I contacted them on Friday and they gave me a very vague response and some articles that I have already seen before. I sent them another email asking for a response from one of their engineers because I can tell the person answering me was not an engineer and he was just trying to find some articles and answer my question. Additional notes. So the electric power must be 6 inches far away from the antenna as it will interfere with the radio signal. I looked at best practices and people are saying that power lines should be perpendicular to the antenna. I tried this myself and it is true. I had lots of timeouts during this ping test, and that was because the power wire was in parallel with the antenna. Now I don't know exactly how Linnea did her testing because I tested this system yesterday and I was successful sending 2048 bytes in 3/4 of a mile and we were in the middle of the city. So the plan is for next time is one of us will be in Gasworks Park and the other will be in Museum of History and Industry in Lake Union, and then we will try to send the 2048 bytes. We know that Gasworks Park is elevated 11 meters, and we concluded earlier that we need 12.5 meters, which means a person 2 meters height should be enough to work. So this, in theory, should work.